Space, the final frontier. Since the dawn of life on Earth, man has looked up at the heavens and discerned ornate patterns sprawled across the night sky. The great unknown was unkempt in paintings on cave walls, and its immensity charted on pages of vellum. While the early caveman used organic pigments to paint a picture of humanity's greatest fascination, astronomers like Galileo, Huygens, and Copernicus used scientific theory and mathematics to breathe life into the stars. Today, the 21st century has seen the visions of Asimov and Baxter come alive. Civilization blossoms and a new age of innovation surrounds us. The Voyager 1, embedded with the golden disk of life, traverses interstellar space at the speed of 11 miles per second. Artificial intelligence powers almost human-like robots. Genome research has enabled cancer detection, and large telescopes stare into the night sky. In the midst of all this novelty, our thirst for space exploration remains primal, and the big questions begin to emerge. What lies beyond the Milky Way galaxy, and what cosmic superstructures exist even beyond that? Where exactly are we in relation to the entire universe? Hidden in the darkest depths of space and time lie strange new worlds. The cosmos beckon us, so let's boldly go where no man has gone before. Life began in the sea. 3.5 billion years ago, the ingredients of life converged to form organic bacterium, and primitive organisms emerged. A few billion years, Jurassic Park, and some ice ages later, human-like apes swaddled out onto the beach and climbed high up the trees. It took many million years of nuts and mangoes to finally make them come down and find fire, food, and the wheel. The cavemen together formed villages, law, mythology, and civilization. Nations soon emerged, followed by urbanization, industrialization, and finally, globalization. What this tells us is that man has an innate drive to explore and expand. Now we look towards the moon and Mars, and hopefully in a few centuries we will have dominion over our own solar system, with human colonies sprouting everywhere. But why stop there? Let's go even further. In fact, let's go as far as we can, to the edges of the observable universe. Let's start at a familiar place. You live here. This is home. Welcome to the planet Earth. She has 3 siblings, Mercury, Venus, and Mars, who together form the terrestrial planets, with the Sun, our beloved star, overlooking them all like a watchful parent. Beyond Mars lies the asteroid belt, which is home to thousands of comets, meteoroids, and Ceres, a dwarf planet. In the neighboring expanse of space, the Jovian planets play a song of ice and fire. Jupiter and Saturn, the gas giants, are made up of primarily hydrogen and helium. Ganymede, one of Jupiter's moons, is larger than even Mercury. Titan, one of Saturn's moons, has a dense, sustainable atmosphere and shows signs of geological activity and is our best bet for finding alien life. They are succeeded by the ice giants, Uranus and Neptune, who have cold cores and radiate very little heat. The area beyond Neptune is classified as the trans-Neptunian region, which has the donut-shaped Kuiper belt, a grand ring of debris similar to the asteroid belt and home of Pluto and several other dwarf planets. We are currently 30 AU from the Sun. 1 AU or 1 astronomical unit is equal to the distance between Earth and the Sun. We find ourselves in the Oort cloud now, a spherical cloud made up of trillions of icy objects that exist at roughly 50,000 AU and stretch as far as 100,000 AU. Most of our own solar system is therefore unknown to us. The point at which the solar system ends and interstellar space begins is not precisely defined because its outer boundaries are shaped by the solar wind and the sun's gravity. But we can estimate that our solar system ends at 125,000 AU, or is 2 light years in size. And now, welcome to the unknown. The galactic map that only mathematics and cosmic telescopes have set foot upon. The solar system is located in the Orion arm of the Milky Way galaxy, a spiral galaxy with over 200 billion stars. The Milky Way also contains 10 billion white dwarfs, a billion neutron stars, and 100 million black holes, but none is as majestic as Sagittarius A, a supermassive black hole which resides at the center of our galaxy and is over 40 million miles across. The Milky Way has a sister, the Andromeda Galaxy, another spiral galaxy which is double its size. Both the galaxies are expected to collide in about 5 billion years and form a supergiant elliptical galaxy nicknamed Milkdromeda. The Milky Way and Andromeda Galaxy belong to a group of 50 closely bound galaxies known as the local group. It is 10 million light years across. The local group is in turn a part of the Virgo cluster, which contains at least 100 galaxy groups and clusters and is 110 million light years across. Whoa, it's a lot to take in. How small and insignificant we truly are. But hang on tight. This isn't even a small crumb of the universe. We still have quite a way to go. The Virgo cluster is only a lobe of an even greater supercluster, Laniakea, which is over 500 million light years across and has more than 100,000 galaxies. So to summarize, galaxies come together to form galaxy groups. The galaxy groups then amalgamate into clusters. The clusters then combine to form superclusters. We have identified about 10 million such superclusters as of yet. Whoa, that is a lot. What do all these form? Superclusters come together to form large quasar groups, supercluster complexes, and galaxy walls, each of these cosmic behemoths being billions of light years across. The scales of measurement and estimation go haywire at this point. Superclusters and galaxy walls and the like all come together to form galaxy filaments, the largest known superstructures in the observable universe. They are massive thread-like formations that exist in the vast void of the interstellar medium. This is it, as far as mathematics, astronomy, and cosmology have dared to venture. We are standing at the edge of the observable universe, with no idea what lies beyond. Even to speculate gives me goosebumps. We have only scratched the surface though, or as much of a surface there can be with space-time constraints. When the notions of dark energy and dark matter, string theory, the multiverse theory, or wormholes are brought in, the geodynamics begin to dance, and our primitive ape minds aren't able to comprehend. But that's a story for another day. We have traveled afar, and this is a never-ending journey. We have made a lot of new cosmic friends and unearthed many mysteries of space and time. I know it's very overwhelming to take in how insignificant our existence seems to be. We are apes with smartphones on a blue dot in the middle of nowhere, who spend hours worrying about what dress to wear or which portrayal of Batman was the best. But that's alright. We are all alright. For we have the greatest gift of all, life. Our imperfections are what make life so perfect. Be grateful for what you have and be accountable towards your actions. And if you ever need inspiration, just look up at the night sky and the stars will become your salvation.